How a refrigerator works, first you need to understand what a reverse heat engine is. So a reverse heat engine is, like its name says, it's basically the opposite of a heat engine. So its goal is to transport energy from a lower temperature to a higher temperature, and it does this by using mechanical work. So by doing work, some of the energy from QL is discharged into the surroundings. The surroundings are at a higher temperature, so the reverse heat engine is able to pump heat out of the system by doing work. The amount of heat that is discharged into the surroundings, which is QH, is equal to the amount of work that is inputted plus QL. So if you wanted to find the amount of work, that would be QH minus QL. The refrigerator uses something similar to this in order to take thermal energy out of a cold object. However, it has a lot more components to it, and it does work slightly differently, which I will talk more about later. So to understand how a refrigerator works, we also have to look into the second law of thermodynamics, which says that heat flows from hot to cold. The first thing that the second law of thermodynamics is going to tell us about refrigerators and reverse heat engines is that there is a theoretical limit to the efficiency of a heat engine. The next thing it tells us is that heat is not going to spontaneously move from hot to cold. So heat needs to be applied, similar to here how you need work in order to get from cold to hot. We also need work in order to go from hot to cold. One of the ways in which work can be done to take thermal energy out of a cold object is by doing compression. So for example, if you have a piston and it has a gas, if you compress that gas, that's going to cause the gas to heat up, and then once you decompress that gas, the gas is going to expand and cool down. And this is really important in order to understand how refrigerators work. So first let's talk about the refrigerant. The refrigerant is a liquid that kind of follows this path. It goes through here around. And when the refrigerant is in the compressor is a motor, and it squeezes the refrigerant, which causes the temperature and the pressure to increase. So like I said before, if you compress a gas, that's going to cause the pressure to increase and it's going to heat up. So here the compressor is a motor that, like it says, it compresses the gas, which causes the temperature and the pressure to increase. And so this is the part of a fridge that is similar to a reverse heat engine, because as you can see, it's going from cold to hot through work, which is done by compression, and then heat is discharged to the surroundings. So next what happens is that the refrigerant goes through the expansion device, where like its name says, the refrigerant is decompressed, which causes it to expand and cool down, like I said here above. So the refrigerant is now a gas. It goes through the evaporator coils and removes heat from the inside. And then it goes around and it goes back into the compressor where it is compressed again, which causes the temperature and pressure to increase again. And so basically the cycle just repeats itself. So in summary, the refrigerant is compressed here and expanded here. And here's where work is done, and then heat is lost to the surroundings over here. And now we can try to understand the fridge as well using a pressure times volume diagram. So you can see here is where work is done. The refrigerant is compressed, which causes the pressure to increase even though the volume stays the same. Then here, when it's going through the condenser coils, heat is released, which the pressure stays the same but the volume decreases. Here is where it goes through the expansion device, where the refrigerant is decompressed, so pressure decreases and volume slightly increases, and then here is where the refrigerant is going through the evaporator coils. And through evaporation, it's able to remove heat from inside the refrigerator, and then the cycle starts all over again.